If you suffer from kidney stones, it's likely that someone at some point has asked you what type of stone you're forming. If you don't know the answer to this question, watch this video. Hi, my name is Joey Weichman, and welcome to Stone Relief. In today's video, we're going to talk about kidney stone identification, which is an incredibly important topic. But before we dive into the different ways that you can accomplish identification, let's talk about why it's important. So, kidney stone identification really is multifaceted in its importance. But one of the first things that you're going to recognize right away is that it will help you select the best possible treatment option. Now, what I mean by this is that the density of your stone, whether it be very, very dense or hard or very weak, there are different treatment options that really better suit a weak stone or a dense stone. Let me give you an example for this. So a stone type that is very, very hard, this is like a calcium oxalate monohydrate stone, and a popular procedure of shockwave lithotripsy. And shockwave lithotripsy with really, really dense stones does not work that well. Typically, people have to go through multiple sessions of shockwave lithotripsy in order to have a successful result of blasting that stone apart to the percentage that it can pass with much more ease than it would in its whole state. So understanding the density is incredibly important when it comes to understanding your treatment options. The other piece of this puzzle is stone prevention. So every single stone type forms for its own unique reason, and we're going to uncover a little bit of that later, but there is no such thing as a universal stone former. I talk to people from all over the world every single day, every single week, and they have a doctor that's like, well, there's no particular reason for why your stone is forming, you just form kidney stones. And at a foundational level, yes, I guess there is a little bit of truth to that. They are part of the population that forms kidney stones. However, there are things that can be done to prevent them if you understand root causes, which is what kidney stone identification will help you do. So kidney stone prevention is another really powerful piece to this. Now, when it comes to the identification methods that we're going to talk about today, there are really three main ones that are in use. First of which is density-based. Next is visual phenotyping, or looking at the stone and understanding what it is communicating to us. And then there's also chemical analysis. And to really get the best picture when it comes to analyzing and identifying your stone, you need to use two of these. And in particular, you need to use visual phenotyping and also chemical analysis. And we'll talk about why in the next chapter. So the first type of identification that we're going to talk about is something called density-based identification. Now, this is particularly useful when you have a stone that is still inside your body and you're looking to determine what the best first-line treatment option is. So what they're going to do is they're going to use a CT scan for this. No other type of imaging, whether it be an X-ray or an ultrasound or a magnetic resonance urography, or MRU for short, none of those things are able to provide density outside of CT. So a CT scan is going to provide us with something called Hounsfield units. And this is a radio density scale that actually uses X-ray images from the CT scan, because that's what it's using, to be able to assign density to not only bones and tissues and other objects in our body, like a kidney stone. And it kind of gives it a shade of gray, and that shade of gray is associated with the density. So they can look into your body, in particular our kidneys, to be able to associate the color of the image coming back to it with a particular density. It's fascinating technology, but it's incredibly useful. So when we get this information, or when you're about to have a CT scan, it's really, really critical that you talk to your doctor about this. For whatever reason here in the United States, most urologists and doctors are not in the practice of asking for density information when they have a CT scan ordered. I don't know any reason as to why of this. It might just be forgotten, and most patients don't have any real use for it, except for you, because you're learning this information today. But you've got to ask. You have to take this into your own hands. They're not going to likely provide it to you. It certainly won't end up in your patient report. So you have to ask them, please make sure that you get density. And this is also known as attenuation in medical language. So here are a few examples of some of the outputs that you might receive from a CT scan. So for example, calcium oxalate monohydrate stones, density value of 879 HU or Hounsfield units. Calcium oxalate dihydrate, 517 HU. Calcium phosphate stones, 435. uric acid stones, 304, and cysteine stones, 150. Now it's important to note here that stones with densities less than 750 and generally are considered weak density stones, and this is not only going to impact what potential treatment you might have if it's surgical, but weak density stones can also be broken up by anti-lithic type of products that you can find on the market. Most of these are supplements, but they also can be whole foods as well, and you can break apart stones without having to go through surgery if they are of a weak density, but a CT scan will tell you this. However, the one weak side of using CT-based density for stone identification is it is almost impossible to identify mixed density type of stones because you're only getting a singular value out of that stone or out of that reading from the CT scan. So if you form a stone type that has multiple components, let's say like calcium phosphate mixed with calcium oxalate, which is a common mixed stone type, you're not going to be able to see that on a CT scan. You're just going to get a single value, but that single value, again, is going to be valuable to be able to understand what type of treatment option is going to be best for that particular stone.
Just a reminder, this information is available in written form on our website. Find the link below in the description.
Next, let's talk about visual phenotyping. Now, this is really where the rubber meets the road when you're talking about understanding root causes for what has led to your stone to form in the first place and what you can potentially do to prevent this stone from forming again. So, a couple things here first and foremost. You need to have the stone itself or really high quality photos of like a previously passed stone. So if stone is still in your body or it's your first kidney stone, this is not going to help you until you've actually passed that stone. Now, another important note here, if you're having this surgically removed or having the stone surgically removed, just like with asking for density with a CT scan, you need to ask your doctor to save that stone. Now, not every procedure is going to have a stone removed in its whole entire form. A lot of times they blast apart the stones and you're going to be passing fragments. So if that is the case and you've got a stone that's been blasted apart, you need to use a urine strainer to be able to collect whatever fragments that you have to be able to help us start understanding the visual phenotype of that stone. Now, when we're talking about visual phenotyping, and I don't mean to throw another bunch of larger words into this gobbledygook here, but we're really referring to morphology. And morphology refers to color, shape, texture, and visual characteristics of something. So these visual characteristics are what differentiate the stone types. Because, for example, with calcium oxalate monohydrate stones, there are 8 different subtypes to them. So calcium oxalate stone is the major stone type, calcium oxalate monohydrate is the subtype, and those 8 other varieties, I call them a subtype, but they're actually tertiary types, and they're all different. They all form for their own reasons. Now, and those different possible root causes could be related to diet, like most calcium oxalate monohydrate stones are linked really truly to diet, but there also might be some health issues that would be contributing to it, such as like Crohn's disease or IBS can also increase that type of stone production. And then there also might be some genetic considerations, like if you have primary hyperoxaluria type 1, or maybe you have cystinuria, which makes you form cysteine stones. So let's just talk about an example here real quick in a little bit more detail. So for example, we have calcium oxalate stones as the top, and I had mentioned that there are 2 different subtypes to this. There's a calcium oxalate monohydrate stone, and then there's a calcium oxalate dihydrate stone. They look very different, and they tell a different tale. So the calcium oxalate stones are typically dark, round, and they're relatively smooth, and they might have little nubules on them in different places, but most of the part they are smooth. The calcium oxalate dihydrate stone, on the other hand, is lighter in color, kind of a light tan, light brown. It's oval shaped, and it's jagged, and it's kind of spiky. So these 2 different stones are of the exact same stone type. However, there are some different things that are occurring that lead to one or the other. So calcium oxalate monohydrate stones are generally considered idiopathic stones, which means we are responsible for forming them. These are related to diet. Calcium oxalate dihydrate stones, on the other hand, are still linked to dietary intake of oxalate. However, they are in the presence of elevated blood calcium, which is also known as hypercalciuria, which is what gives them their lighter shade, different formation shape as well, and be a little bit more jagged. So again, there are multiple different stone types. A ton of them. They're all looking a little bit different, and they all tell a story, and that is the power of visual phenotyping. Now, just like with density-based identification, there is a weak side of this. They are still weak at identifying mixed stone types, because a lot of times on the surface, a stone looks a certain way, and you're like, oh, it's that. But if you're going to do what we're going to talk about next, which is a chemical analysis, you might find out that there are other components to this as well that are not visible to the naked eye. So let's talk about chemical analysis next. Okay, let's dive into the last identification technique that's out there. Now, this is going to be chemical analysis, and an important piece here is that you need to have your stone. Fragments will work if you've passed or you've had a surgical procedure where you're passing fragments. This is totally fine. That will work for the purposes, but ideally you have a larger stone. And again, just like before with the visual phenotyping, if you're having surgery and they're intending on removing the stone whole with a little basket grasper, or you're having a percutaneous nephrolithotomy where they're just going to remove it through that tubule that they've inserted through your side and into your kidney, ask the doctor. Make sure that you let them know that you want to have it analyzed or they provide it to you, because otherwise it's just going to go in the trash. Now, what happens when they have this stone is most laboratories use a process called FTIR, and this stands for Fourier Transform Infrared Spectroscopy. Mouthful, right? But basically, here's what's happening with your stone in order for them to be able to identify the stone type. So they're going to clean it, they're going to dry it, and then they're going to grind it into a fine powder. They're then going to put that fine powder on top of a crystal. And once it is on top of that crystal, they're going to apply infrared beams to this, because that application of the infrared beam mixed with the ground kidney stone is going to provide an output spectrum that they're then going to use to compare to known kidney stone types. The best way to think of this, like that output spectrum that's created with the kidney stone dust, if you will, in the crystal, it's like a fingerprint. And every single stone type has its own unique fingerprint that's able to be identified through FTIR. So once they're able to understand what those compounds are, you actually get an exact percentage composition of your kidney stones, which is going to help you when you go to look at visual phenotyping at some point in time after you have these results as well. Because if you have a mixed stone type, you're going to be able to start to understand multiple factors that could potentially be leading to kidney stone formation. And again, with regards to mixed stones, chemical analysis is the gold standard. Density-based identification is not strong, visual phenotyping is not strong, but chemical analysis, it's where it's at. And when you combine both visual phenotyping with chemical analysis, this is where you start to make some huge strides in terms of preventing future kidney stones. If you'd like to join a community of men seeking to avoid surgery and prevent their kidney stones naturally, visit our website. See you in the next video.